Bismillahirrahmanirrahim. Hello everybody. Today we are concerned by an exercise about supremum, upper bound, lower bound, infimum. So we are concerned by this kind of question. So how we can deal with this kind of problems? There is many ways. So there is many ways, but in this case the most I think simple way is to consider B as the union of two sets such that B1 is equal to 1 plus minus 1 over 2n power 2n over 2n, n is in n, and B2 is equal to 1 plus minus 1 power 2n plus 1 over 2n plus 1, and n is in n o, n 0 with 0. If we wish to use just n, we can write here minus 1 and we start from 1. If we take plus 1, we start from 0. So this one is equal to 1 plus 1 over n in n, and this one is equal to n, and 1 minus 1 over 2n minus 1, and n also in the natural number n. We know from previous properties, so we know, or we are supposed to know, that the supremum of B1 union B2 is equal to the maximum between the supremum of B1 and the supremum of B2, and the infimum of B1 union B2 is equal to the minimum of the infimum of B1, the infimum of B2. So we will use these two simple and so famous properties to deal with our exercise. Starting from here, we have two ways. Once again, we have two ways. Deal with B1 and B2 as sets, just as a set. For those who doesn't know about sequences, and for those who know sequences, they have a way. So I will suppose that we are not familiar with sequences, and we will deal just as we are concerning just by sets. So keep this in our minds, and let us deal without using sequences. Actually, if we know about sequences, we can say that in this case, for example, this is a non-increasing, so it is a decreasing sequences. So the supremum of B1 is equal to the first one, so 1 plus 1/2, so the supremum is 3 over 2, and the infimum is 1. For this one, this is a sequence which is decreasing. This one is a sequence which is decreasing. So the first term is for n equal to 1. This means 1. So 1 minus 1 is equal to 0. And the limit is equal to 0. So 1. Since all this sequence is an decreasing one, so the first term is equal to 0 and the last term is equal to 1. I mean increasing one, non decreasing. I mean increasing one. So the first term is for n equal to 1, 0. So this is the infimum. And the supremum is when n goes to plus infinity, which is 1. We can deal like this, but I am not going to deal like this. This is a solution actually. So what we can do, we take the first one. So B1 isn't empty. Why? Because for n equal to 1, we have 3 over 2 belongs to B1. So this is not an empty set. Secondly, one plus 1 over 2n, this is less than or equal to 3 over 2, and this is strictly greater than 1. Why? Because here we add positive terms to 1, so this is strictly than 1. And this one, 1 over 2n, this is the maximum that we can guess for this value. So all the others are less than or equal to 1 over 2, which is 3 over 2. This is for B1. So B1 is bounded. The same thing with B2. So for B2 isn't empty. Why? Because for n equal to 1, we have this is equal, so we have for n equal to 1, we have 1 minus 1, so we have 0, which belongs to B2, so it is not empty. And we have 1 minus 1 over 2n minus 1. We are sure that this is less than 1, are sure, because 1 we take out a positive number, so this is less than 1, and this is greater than or equal for n equal to 1, so we have 1 over 1 minus, so this is greater than 0 for all n in n, and this is true for all n in n. So they are bounded, and this is also bounded. B1 is bounded, B2 is bounded, so the union is a bounded set. So from this double inequality, we we suspect here, just we suspect that the supremum of B1 is equal to 3 over 2, and the infimum of B1 is equal to 1. And from here, we suspect, I say we suspect, that the infimum of B2 is equal to 0, and the supremum of B2 is equal to 1. So if we take B1 and B2, and if we use the two properties that I already wrote here, we will suspect that the supremum of B, the supremum of B is equal to 3 over 2, and the infimum of B is equal to 0. Let us verify that this is true. Let us verify that this is true. So I need I need to clean this place. So B1 1 plus 1 over 2n and in n, and B2 is equal to 1 minus 1 over 2n minus 1, and belongs to n. Let us verify that 3 over 2 is the supremum of B2. Using the characterization of the supremum, we can write that for all for all B1 from B1, we have what? We have B1 is less than or equal. B1 takes this form. B1 take this form. 1 plus 1 over 2n is less than or equal to 3 over 2. And second, is the following true? For all epsilon greater than 0, can we find an element B1 epsilon from B1 such that what? Such that the supremum, the 3 over 2, which we suspect that this is the supremum, 3 over 2 minus epsilon is less than, strictly less than 1 plus 1 over 2n, and this is less than or equal to 3 over 2. This is true from this one, so we have just to deal with this inequality. Can we find n for which, for every epsilon greater than 0, this is possible? So we start from this inequality. Epsilon is supposed given, and we search the existence of at least n. 1 plus 1 over 2n, and this is equivalent, if we take this from here, minus 1, so we will get 1 over 2 minus epsilon less than 1 over 2n. Here we have cases. This is strictly greater than 0. So if epsilon is greater than or equal to 1/2, this will be negative, and we know that all positive numbers are greater than all negative numbers. So the inequality, if epsilon is greater than or equal 1/2, the inequality is trivial verified, trivial. This is true. Positive number is greater than a negative number. So what we do, we suppose that we take the case 1 epsilon is strictly less than 1/2 and strictly greater than 0. So we deal with this case. In this case here, so if we take epsilon less than 1/2 and greater than 0, this quantity is positive, this value is positive. So we will get 1/2 minus epsilon less than 1/2n. So if we inverse, we can for example this write this equal to epsilon over 2, and we cancel 2 with 2. So we get what we get. If we take the inverse, we will get n, and we inverse the inequality is less than 1 over 1 minus 2 epsilon. Such natural number, does it exist? So we have to prove this or disapprove this. Epsilon is between 1/2 and 0. We try to find bounds for this equation, this quantity, this value. So 0 is less than 2 epsilon less than 1, and minus 1 is less than minus 2 epsilon less than 0. If we add 1, we will get 0 less than 1 minus 2 epsilon less than we add 1 less than 1. If we take the inverse, we will get 1 less than 1 over 1 minus 2 epsilon. So this value, which is this one, is strictly greater than 1. Can we find a natural number which is less than this value? The answer is yes. And the natural number, the candidate, is n equal to 1. So n equal to 1 is a natural number. And this natural number is strictly less than 1 over 1 minus 2 epsilon. So does an element from B1 exist such that this is true? Yes. For any epsilon, yes. What is the number is for n equal to 1, which means 1 plus 1 over 2, 3 over 2. It will be true. And actually, if we take n equal to 1, we see without any problem that this is true for any epsilon. So We answer the first question. We answer the first question. Now suppose that if this value is less than 1, so greater than 0, can we find the natural number? In this case, no. Why? Because the natural number will be equal to 0, but 0 isn't here, so we are not allowed to take it. And if you choose by a bad way that the supremum, for example, is equal to 2, in this case you will not be able to find a natural number, an adequate natural number, such that your inequality holds. So this is about the supremum of B2, the supremum of B1. And secondly, we will try to prove that the infimum of B2 is equal to 0. So we will deal with the same technique. We confirm now that 3 over 2 is the supremum of B1. So the supremum of B1 is equal to 3 over 2. And actually, 3 over 2 is a maximum. Why is a maximum? It is a maximum because we can find n equal to 1, so that 3 over 2 belongs to B1, because 3 over 2 belongs to B1. This is what we did first. Second result, we prove that the infimum, we suspect that the infimum of B2 is equal to 0. We suspect. So we have to verify this. To this end, we have for all elements B2 from B2, we have B2 is less than 1 and greater or equal to 0. So this is okay. Second, we have to prove by characterization. So for all epsilon greater than 0, can we find an element from B2, so B2 epsilon from B2, such that 0 is less than or equal to B2 epsilon, and this one is less than strictly of 0 plus epsilon. If we translate this in terms of element of B2, we will write 1 minus the form of B2 epsilon is this one, 1 minus 1 over 2n minus 1, strictly less than epsilon. If epsilon is greater than 1, sure, because 1 minus, so epsilon is less than 1, strictly less than 1, to deal if this is possible. In this case, what we can do, we take this one from this one and this one from this one. We will get 1 minus epsilon less than 1 over 2m minus 1. Change of places. If epsilon is greater than or equal to 1, this is trivial. Why? Because here we will get 0 or negative, and this is a positive, so it is always true. Suppose that that epsilon is less than 1 and greater than 0. In this case, we can take the inverse. If we take the inverse, what we will get, what we will got, or get, what we will get, 1 over 1 minus epsilon, okay, greater than, take the inverse, greater than 2n minus 1. So this one. So 2n is less than 1 over 1 minus epsilon plus 1. So n is less than 1/2 from this one. Does such an exist? So to be able to confirm this, we need to evaluate the interval of this quantity. We are back. We suppose that epsilon is less than 1 and greater than 0. So minus epsilon is less than 0 and greater than minus 1. So 1 minus epsilon is less than 1 and greater than 0. Then 1 over 1 minus epsilon is greater than 1 and less than plus infinity. If we add 1, so we can add 1 here and 1 here. If we take 1/2, we take 1/2. Result, this is equal to 1. Take n equal 1. It fits our situation. Finally, we proved that 0 is the infimum of B2. Conclusion. Infimum of B2 is equal to 0, and actually is equal to the minimum of B2. Why? Because 0 belongs to B2. This is true for n equal to 1. It's about B. The supremum of B is equal the maximum of the 2 supremum, and we proved that this is true. And the infimum of B is the minimum of the 2 minimum, and the two minimum here are the minimum of the 2 infimum, and this is equal to 0. Bounds, this is equal to minimum, okay. This is equal to minimum of B, and this is equal to the maximum of B. Bounds, upper bounds is the set 3 over 2 plus infinity. Lower bounds is the set minus infinity 0. This ends this video. Thank you. Hope that it was clear. See you next time. Or yeah, I think that this is all for this video. Thank you very much. See you next time.